Okay, good morning. Today we move forward in hybridization and orbital formation. Okay, we have discussed about the overlapping. In previous lecture we have discussing about the overlapping of the orbital. Today we discuss about hybridization. Hybridization means what? Mixing of orbital. Different orbitals are. We have seen orbital S, P, D and F. If mixing of orbital takes place, then it will give the hybrid orbital. Hybrid orbital means energy becomes same. The orientation becomes same. So what is hybridization? First we discuss that. Hybridization means mixing of orbital to form bond formation having equal energy and shape also becomes equal. Different silent feature related with the hybridization is when hybridization takes place and which are the silent features that we discuss. First one, number of hybrid orbitals is equal to the atomic orbital. Means whatever atomic orbital involved, suppose atomic orbital involved is 2, then hybrid orbital also it will be. So number of atomic orbital is equal to the number of hybrid orbital. Second, hybrid orbitals are always equivalent in shape. Their shape is equal and energy is equal. This is very important. When hybridization takes place, their shape becomes equal. Means if S and P hybridization takes place, then shape will turn in such a way that energy remains constant. Means having equal energy. Previously, if it is atomic orbital, then energy difference is there. But when it turns to hybrid orbital, then its shape and energy becomes equal. Number third, hybrid orbitals are more effective in bond formation as compared to the atomic orbital. Means the chance of formation of bond become predominant as compared to atomic orbital. So if hybridization takes place, bond formation take more easily. That is number third. Number four, hybrid orbital are directional in space. Means they are arranged in space in such a way that bond formation takes place and repulsion between the bond is minimum. Repulsion between the bond is minimum and it forms the stable arrangement in the space. Means it's arranged in the space in such a way repulsion is minimum and stable configuration or arrangement will be there. If it is 2 orbital mix, then it will form linear shape. If 3, then trigonal planar. If 4, then tetrahedral or square planar. Similarly, different arrangement, different orbital mix and different arrangement will take formation. Now we discuss about the types of hybridization. Okay? Type of hybridization means which orbital mix together. As for example, sp hybridization, sp2 hybridization and sp3. First we discuss 3 type of hybridization. So second topic is related with type of hybridization. And then we take a few examples related with that. Type of hybridization. There are total, we discuss 3 type of hybridization. First one is sp hybridization. Second one that is sp2 hybridization. And third one is sp3 hybridization. Here sp hybridization is what? One s orbit and one p orbit will mix together. Here one s orbit and 2 p orbit mix together. And here one s orbit and 3 p orbit, px, py and pz mixed together and form hybridization. That is known as sp3 hybridization. If this mixing will take place, then it has an equal energy. That is known as hybridization. Means suppose s orbital, that is spherical in shape, if it is mixed with p orbital, then hybridization involves the change in the energy level. So this orbital, p orbital, it changes shape. The middle logs become smaller. Suppose it is minus and minus and outer logs become positive. So this is known as hybridization, mixing of orbital. So it take this shape. This is sp hybridization. Similarly, sp2 hybridization. Okay, sp2 hybridization, one s orbit and two p orbits are in one. Then it is sp2 hybridization. Okay, sp2 hybridization. So we will take sp2 hybridization, one s orbit, one p orbit, two p orbit means this direction and this direction. Then total 3 orbitals are mixed, and at an angle level with this 3 orbital px, py and this s orbital. If it is mixed, then 3 type of structure will be obtained and its angle will be what? 120. Plus, plus, plus and minus, minus. So here you can see logs are rearrange their shape and take the new structure, new geometry, that is known as hybrid. Then electron transfer and bond formation take place more easily. If it is sp3, then it takes the structure of tetrahedral shape. The bond formation take place. Remember how to draw tetrahedral, make the triangle and then make the shape, and in all direction 4 logs are involved. Here all 4 direction tetrahedral structures are n. Remember it's like this only. Here it is trigonal pillar, here it will be tetrahedral. Mixing of orbital will be 1 s orbital and 3 p orbital makes the bond with each other and forms tetrahedral structure. Remember, tetrahedral structure, trigonal pyramid type. As for example, CH4. With CH4, then sp3 hybridization. Here, first example is BeCl2. Here BeCl2. Then it will form sp hybridization, BeCl2. Second one, that is sp2 hybridization. Then it is BeCl3. Example BeCl3. You remember that chlorine 3 atom will form its 3 electrons goes in one s orbit, p orbit and p orbit in boron. Similarly, chlorine 2 atoms goes to barium, one in s orbit and one in p orbit. Similarly, carbon 4 electron goes in hybrid orbital of carbon. The 4 hydrogen electron goes to 4 carbon electron and forms hybridization. Again I have sp3 hybridization. Here you can see carbon with the configuration 1s2, 2s2 and 2p2. So here you can see 4 electrons are there. Carbon star means when it becomes hybrid, then 2s1, 2p3. So here you can see 1 electron from s orbital goes and jumps to p orbital. So total 4 unpaired electron form take place, and all these electrons are unpaired and having equal energy, and this will mix with hydrogen and form CH4 geometry. That geometry will be tetrahedral, and involved orbital involved is 1s orbital and 3p orbital involved. That's why it hybridization is known as sp3. Similarly, classification of this hybridization will take place in terms of carbon. Then total 3 classification will be there. Okay, hybridization in terms of organic compound, then in terms of carbon. We have first one, that is sp3 hybridization. So in any alkane compound, hybridization is sp3. For example, CH4, CH3, 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 CH2, CH3. If there is single bond, then hybridization is sp3. Remember this structure is planar here triangle. If hybridization is sp2, then example is alkene. Remember, example is alkene means first one will what come? That's called CH2 double bond CH2, that is ethene. Next one CH2 CH double bond CH2 means propane. If there is double bond, then hybridization will be sp2 instead of sp3. Why? Because one bond, that is pi bond, we have to not to consider. If energy decreases, remember this. If pi bond formation takes place, then one orbital you have to omit. So instead of sp3 hybridization, it will be what? sp2. Similarly, sp hybridization, then it is what? Alkyne. Okay, alkyne means it is triple bond. So this will take place in CH triple bond CH means ethine. Here there are two pi bond and one sigma bond. So that sigma bond will form sp hybridization. Other p orbital are involved in pi bond formation. That's why you have to not to consider in hybridization. So this is the hybridization sp. In alkyne means in ethene. As for example, ethyne, propine or whatever. You can here take propine also. CH3 C triple bond CH. Then it is propine. Okay, hybridization is sp hybridization. So remember, if it is triple bond, then if it is double bond, then sp2 hybridization. If it is single bond alkane, then sp3 hybridization. In homework, try to draw the structure of alkane, alkene and alkyne with hybridization. Okay? Thank you.